Today we are going over reviewing really operations with radicals. We're going to be doing simplifying radicals, adding, subtracting radicals, multiplying radicals, and dividing radicals. So for the do now, what I want you guys to do is the first 1 through 4 is simplifying radicals. If you need a little refresher on how to simplify radicals, there's the little thought bubble here to remind you how to simplify radicals. And the next 1 through 4 is just simplifying, adding like terms. So take 3 to 5 minutes, pause the video, and play the video once you are done. Number 1, the square root of 72. Good rule of thumb, you always want to look for the highest perfect square that divides the number inside the radical. So the highest perfect square that divides 72 is 36. So this would now become radical 36, radical 2, because radical 72 divided by 36 is 2. Then radical 36 is 6, so that would simplify to 6. Radical 2 would be your completely simplified radical. Say you didn't see that the highest perfect square that went into 72 was 36. That's completely fine. Say you thought it was 9. So we would separate that into radical 9. And then what times 9 gives you 72? That would be 8. So radical 9 is 3. Radical 8. But then you'd have to notice, wait, 8 also has a perfect square that divides it. So that would be 3 radical 4 radical 2, which would be 3 times 2 radical 2, which would simplify to 6 radical 2. So you get the same answer, just a little bit more work, a couple more steps. But if you don't find the largest perfect square, don't worry. You can keep on finding perfect squares that divide the number inside the radical, the radicand, and you will obtain the same answer. Looking at number 2, simplify radical x to the 11th. So x to the 11th is not a perfect square. The highest perfect square that divides x to the 11th is just the smaller even power. So not x to the 11th, but just subtract 1 to make it an even power, and that would be x to the 10th. So it'll be square root of x to the 10th times square root of what's left over is just an x. So square root of x to the 10th would be x to the 5th. Then we can't simplify square root of x anymore, so it'll just be x to the 5th square root of x. If you're wondering how I got that x to the 5th, think about the rational exponents we just did. So x to the 10th, square root of x to the 10th is really x to the 10th to the 1/2. And then you multiply, once power to a power, you multiply the exponents, and that'd be x to the 5th. So that's how you get x to the 5th. 243, what's the highest perfect square that goes into 243? Don't be afraid to just get the calculator out and start dividing 243 by, I would start with the lowest perfect square, then to the highest perfect square you can think of. So 243, and I'm going to start with, we don't want to start with 1. 1 times 1 is 1. That's a perfect square, but that's not going to get us anywhere. So the next perfect square would be 2 times 2, which is 4. 244 does not divide 243, so let's do 3 times 3, which is 9. Oh, so 9 does divide 243, but it looks like there could be a higher number, so I'm going to do 243 divide by 16. That doesn't work. I'm going to skip 25 because 243 doesn't end with a 5 or a 0. So now I'm going to do 36. Nope. So we have 9 so far, so let's keep that. You can write that down if you want to. 243 divided by 7 times 7, which is 49. That doesn't work. 243 divided by 64, 8 times 8. Nope. 243 divided by 81. Oh, there we go. So that's going to be our highest perfect square because 243 divided by 81 is 3, which is a prime number. So we can't get a larger perfect square than 81 that divides 243. So this would now be radical 81 times radical 3. That separates the 243. And then x to the 8th is a perfect square, so we can just leave it as radical x to the 8th. Simplify each radical. Radical 81 is 9. Can't do anything with radical 3. Radical x to the 8th would be x to the 4th. And then just rewrite it with the radical at the end. That would be 9. X to the 4th, radical 3. That would be your answer. Number 4. Radical 1728 times a to the 15th times b times c to the 29th. So first thing I'm going to do is I'm going to break it up. So it would be radical 1728 times radical a to the 15th times radical b times radical c to the 29th. What's the highest perfect square that goes into 1728? I'm going to show you guys a little trick I like to do to find that. So it is quite a large number. What I like to do is, so we take 1728 in our calculator, and I'm going to divide it by, it's even, so I'm going to start with 4. And I always start with 4, so I used to just skip around, but then you forget which ones you tried, and you think no perfect square goes into it, but you might skip like one in the middle, like 36. So I would always just start at the lowest and go to the highest. So divide it by 4. Oh, okay, it's divisible by 4. So 432 times 4 is 1728. And let's take our quotient, 432, and let's divide that by 4 again. Let's see if it is, so that is again divisible by the perfect square of 4. We still have another even number, so that might be divisible by 4 again. I'm going to try divisible by 4. Look at that. It is divisible by another 4. And we have 27. Is there a perfect square that divides 27? Yeah, there's 9. So if I divide 27 by 9, I get 3. So what we do with that information, we take the first 4, and this is how you can find an easier way of finding the highest perfect square that goes into a very large number. Take 4. We have 1 4. From there, we have a second 4, so 4 times 4. We have a third 4 times another 4 times 9, and this will be the highest perfect square that goes into 1728. 576. Didn't even know that was a perfect square. So now we're going to separate 1728 into radical 576, which is a perfect square. We'll figure out what the square root of 576 is in a second. And then the last number we had was 3 after we divide 27 by 9. So it'll be radical 576, radical 3. And now a to the 15th, the highest perfect square that goes into a to the 15th will be a to the 14th. And we're left over with an a. B just stays square root of b. And c to the 29th would be radical c to the 28th times radical c. Now let's check what radical 576 is. So radical 576 in our calculator, that simplifies to 24. So it'll be 24, radical 3. Radical a to the 14th is a to the 7th, radical a, radical b, c to the 14th, radical c. Write everything underneath one radical and bring out the a to the 7th and c to the 14th in front. So that would be 24, a to the 7th, c to the 14th, square root of 3a, b, c. And that's our simplified radical version of radical 1728, a to the 15th, b, c to the 29th. And you could do, there's a lot of different methods to getting that radical 576 or just getting to 24 radical 3. You could have done a lot of different methods. I just find that's like the easiest way of doing that. So the second pair of 4 questions. We're combining like terms here. 5x plus 13x, those are like terms. Add them together. You get 13x is 5x plus 8x. 2 is 5x squared plus 8x. It's 5x squared, not 5x. So that makes these unlike terms, so we can't add them together or combine them, so it just stays 5x squared plus 8x. Looking at number 3, similar idea with radicals. Notice these radicals, it's radical 5 radical 2 plus 8 radical 2. They have the same radicals, so they are like terms. So that would be 13 radical 2. And looking at number 4, these do not have the same radicals. They have a 5 radical 3 and then an 8 radical 2. These are not like terms, so you cannot combine them. So that would be 5. That would be 5 radical 3 plus 8 radical 2. We cannot combine them. What should we know by the end of the day? It's a lot of review. I can completely simplify radical expressions with both numbers and variables. I can explain the process of completely simplifying a radical. I can add and subtract radical expressions. I can multiply radical expressions. I can divide radical expressions. And I can explain the process of dividing radical expressions. Let's go to the next page. So now we're going to talk more about simplifying radicals. I want everyone to do the top left one. So I want everyone to simplify radical or square root of 108 times x to the 9th times y to the 13th. Take a minute, pause the video, simplify that, and then play the video once you're done. So the highest perfect square that goes into 108 would be 36. So this would be radical 36. Radical 3 times x to the radical x to the 8th, radical x, y to the 12th radical times radical y. That would simplify to 6 rad 3, x to the 4th rad x, and y to the 6th rad y. Get everything that's not inside of the radical out in front, and everything in the radical under one radical. So that would be 6 x to the 4th y to the 6th radical or square root 3xy. And that is our simplified radical. So let's look at the next one, the one to the right of it. What's different about this one than the one we just did? Well, this one now has a cube root, not a square root. So when we simplify this, we're going to simplify it instead of the square root of 108, we're going to think about it as the cube root of 108 times the cube root of x to the 9th times the cube root of y to the 13th. So we're not looking for perfect squares anymore. We're looking for perfect cubes. So a perfect cube would be like 2 times 2 times 2, which is 8. Or 3 times 3 times 3, 27. 4 times 4 times 4, 64. 5 times 5 times 5, 125. And the list goes on. So I would do the same exact thing in the calculator as we do for square roots, but this time divide it by perfect cubes. So I'm going to take 108, and I'm going to divide it by the first perfect cube. I know the first perfect cube is 1, but we don't want to do that. We divide it by 8. Doesn't work. Let's do the next perfect cube. Doesn't divide evenly. 108 divided by 27. Oh, that went in evenly. Perfect. So now we're going to split up the cube root of 108 into cube root of 27 times the cube root of 4. So cube root of 108 would be cube root of 27, because that is a whole number, times the cube root of 4. And then cube root of x to the ninth. X to the ninth is actually a perfect cube. Think about it as using our rational expressions. Our rational exponents would be x to the ninth to the 1/3, which would be x to the 9/3, which is x to the third. So that simplifies to x to the third. You could also think of it as x what times what would give you x to the ninth when it's all the same. Well, that would be x to the third times x to the third times x to the third. Similarly, we have to do the same thing with the cube root of y to the 13th. It's really just the highest multiple of the highest multiple of 3 that is 13 or below 13. So the highest multiple of 3 would be, or the largest perfect square that goes into y to the 13th would be y to the 12th times cube root of y. Now simplify each of the cube roots. 3, cube root of 4 stays cube root of 4. We already simplified that one. That will be y to the 4th times cube root of y. And do the same thing. Everything outside the radical goes out in front. 3 x to the 3rd, y to the 4th. And everything inside the cube roots stays inside a cube root, but all under 1. So that would be 4y. Cube root of 4y. And that is our simplified cube root. Let's go on to the next 4. I want you to take, 2 to 3 minutes, do the next 2, so the square root and the cube root one. Pause the video, play it once you're done. We're going to go over how to do both of them. So the highest perfect square that goes into 160 is 16. And I simplified each of the variable radicals from there. Let's talk about the next one, because the next one's the cube root. So the cube root of 160, same number, a to the 5th, b to the 6th, c to the 7th, d to the 8th. We want to look for cubes, perfect cubes here, not perfect squares, because it's cube root. So we're looking for perfect cubes. So I'm going to separate the highest perfect cube that goes into 160 should be 8. So it'll be cube root of 8, and then 160 divided by 8 would be 20 times cube root of 20. Highest perfect cube that goes into a to the 5th, it's going to be a multiple of 3 that is 5 or below. That would be a to the 3rd. What's left over would be cube root of a squared. 6 is a multiple of 3, so it is a perfect cube. So that would just be cube root of b to the 6th. And then c would be cube root of c to the 6th, c, because the highest multiple of 3 at 7 or below is 6. And then we do the same thing with 8, or with d. So it'll be cube root of d to the 6th, then cube root of d squared. What's left over? Simplify each cube root. We get 2 cube root of 20, a cube root of a squared, b squared, c squared, forgot my cube root on that, c, cube root of c, d squared, and then cube root of d squared. Take everything outside the radical, put it out front, so that would be 2a, b squared, c squared, d squared, and then write everything in the cube root underneath 1 cube root times the cube root of 20, a squared, c, d squared. And that is our completely simplified cube root. What's different about the next one on the bottom left than the other 2 we just did? Because the same thing is inside of the radical. Take a look at what the index is on the radical, though. It's the 4th root. So instead of taking out the perfect squares or perfect cubes. In this case, we're going to have to think about the perfect fourths. So that would be 2 times 2 times 2 times 2, which would be 16. 3 times 3 times 3 times 3, which would be 81. And the numbers go on. So we want to do the same thing as we have been doing. So we'd separate it by, it'd be the cube root. We want to think about as the fourth root of 160 times the fourth root of a to the fifth times the fourth root of b to the sixth times the fourth root of c to the seventh times the fourth root of d to the eighth. And now we have to figure out the largest perfect to the fourth power number that goes into 160. Well, actually, you guys could take the calculator and start dividing by 16, divide by 81, divide by 4 to the fourth. But I see 16 and 160. That's easier to see. So that's 160 divided by 16 is 10. So I know this is going to break up into the fourth root of 16, which is 2, and the fourth root of 10, because 160 divided by 16 is 10. And then think about what we did up here for the cube root. We wanted the highest multiple of 3 that was the exponent or lower. So for the fourth root, the easy way of doing this is the highest multiple of 4 that is the exponent or lower. So if I look at a to the fifth, I would split this up into the fourth root of a to the fourth. What's left over is a times the fourth root of a. Then the fourth root of b to the fourth times the fourth root of b squared. C to the seventh, fourth root of c to the fourth times the fourth root of what's left over, c to the third. And 8 is a multiple of 4, so d to the eighth is a perfect to the fourth power, so that would be d squared. So now we would simplify each fourth root that we can. The fourth root of 16 is 2. Fourth root of 10 stays fourth root of 10. Fourth root of a to the fourth would be a. Fourth root of a, b. Fourth root of b. Fourth root of b squared times c. Fourth root of c to the third. D squared. And the process is still the same. Everything outside of the fourth root goes out front. So that would be 2ab c times d squared. And then everything else gets under a fourth root. So it would be fourth root of 10ab squared c to the third. And that is our simplified fourth root. I want you guys to take a look at that last one. Knowing what you know of what we've done for the past 3 simplifications, I want you to see if you can figure out how we're going to simplify that last one. It's a fifth root this time. Pause the video, take 3 to 5 minutes, try and simplify that, and then we will go over it. Since this one is simplifying a fifth root, we want to do the same thing, so we separate it. That would be the fifth root. This makes it easier to think of 160 times the fifth root of a to the fifth times the fifth root of b to the sixth times the fifth root of c to the seventh times the fifth root of d to the eighth. And now instead of trying to get the highest perfect square, perfect cube, or perfect fourth power of a number that divides each of these, we need to find the highest fifth power of number that divides that. So 2 times 2 times 2 times 2 times 2, which is 32. Or we can think of 3 to the fifth power, which is 243. 4 to the fifth power, 5 to the fifth power, the list goes on. So the highest perfect fifth power, that fifth root that goes into 160, would be, try 160 divided by 32. 160 divided by 32. That is equal to 5. So 32 divides 160. So I'm going to separate the fifth root of 160 into the fifth root of 32 times the 5th root of 5, because that was the leftover number when you got 160 divided by 32. Now, we don't want a multiple 4 or 3 or 2 to simplify the variables with an exponent. We need the highest multiple of 5 that goes into the exponent. So if I look at a to the 5th, that is a multiple of 5. So I'm going to keep it like 5a to the 5th. Or you can simplify it to a if you want to. B to the 6th would be 5b to the 5th times the 5th root of b. Then the 5th root of c to the 5th times the 5th root of c squared. And then the 5th root of d to the 5th times the 5th root of d to the 3rd. Simplify each 5th root. That would be a 2. 5th root of 5 just stays 5th root of 5. 5th root of a to the 5th is a. 5th root of b to the 5th, is b. 5th root of b. C, 5th root of c squared. Can't simplify that. Then d, 5th root of d to the 3rd. And it's the same process every time. You bring everything outside of the radicals. The 5th roots in this case would be 2a, b, c, d, and put everything under the 5th root under 1 5th root. So that would be 5th root of 5, b, c squared, d to the 3rd. And the process is similar for a 6th root, 7th root, 8th root, 9th root, 10th root. So you guys can simplify any radical with any index. It's just the same process. Let's go to the next page. When adding and subtracting radicals, we must have like terms. It's just like adding 7x and 3x. We have to have like terms. You can't add 7x plus 3x squared because they're not like terms. So when you look at a, b, and c, there's no variables here, so we just need to look at the radicals. So it's 7 times radical 6 plus 2 times radical 6. So we have the same radical. These are like terms. We just need to add their coefficients. 7 plus 2 is 9, then radical 6. Looking at b, we have 4 radical 5 plus 3 radical 10. These are unlike terms, so we can't combine them. So it just stays 4 radical 5 plus 3 radical 10. Nothing we can do there. And C, we have common terms here because the radicals are the same. So radical 14 minus 3 radical 14 would be, we subtract the coefficients. Remember, what's the number in front of that first term? What's the number in front of rad 14? It's really 1. So we're doing 1 minus 3 to get negative 2. So our answer should be, our coefficient would be negative 2 radical 14. That's for adding and subtracting like terms. What about if we're going to add and subtract unlike terms? So look at the first one. 3 radical 24 minus 9 radical 6. It looks like these are unlike terms so far, but if we can simplify one of the radicals, maybe we can get them to be like terms and then we can combine them. So let's look at the first one. 3 square root of 24. Let's simplify that. The square root of 24, the highest perfect square that goes into 24 is 4. So that would be 3 square root of 4 square root of 6 minus 9 square root of 6. Continue to simplify that. 3 radical 4 is 2. We can't do anything with the square root of 6 minus 9 square root of 6. Multiply the 3 times 2. We would get 6 square root of 6 minus 9 square root of 6. Now we do have like terms. They both have radical 6s. 6 radical 6 and 9 radical 6 are like terms. So subtract them and you would get negative 3 radical 6. So when we have unlike terms, make sure you simplify all the radicals, because they could be like terms in disguise, and then combine all the like terms if there are like terms. Let's look at the next one. Negative radical 27 plus 2 radical 12. Well, the highest perfect square, let's first do radical 27. That goes into 27 would be 9, so that'd be negative 9 radical 3 plus 2. And is there highest perfect square that goes to 12? There is, it's 4. So that'd be radical 4, radical 3. Continue to simplify, that would be negative radical 9 is 3, radical 3 plus 2. Radical 4 is 2 times 3. You would get negative 3, radical 3 plus 2 times 2 is 4, radical 3. Look at that. They were actually like terms. So now we can simplify and combine the like terms. Negative 3 plus 4 would be 1, radical 3. But don't write it as 1 radical 3. 1 times radical 3 is just radical 3. So please just write it as radical 3. That is simplified all the way. That's adding and subtracting. On the next page, we're going to do multiplying. On the next page, multiplying radicals, we have a little step-by-step multiplying radicals box over here that I made. So follow that. It says step 1, simplify any radicals possible. Then step 2, we multiply the coefficients. Then multiply the radicands. And the final step is just to simplify the product if we can anymore. Step 1 and step 2 are really interchangeable. I just recommend simplifying any radicals first because it lets us work with smaller numbers, which is easier and you're less likely to make a mistake with smaller numbers. So looking at the first one, radical 5 times radical 10. Step 1, simplify any radicals possible. Well, radical 5 and radical 10 we can't simplify anymore, so that's done. Step 2, multiply the coefficients. Well, the coefficients are 1 and 1, so we don't have to multiply any coefficients there. But then multiply the radicands. Radicands, what's inside the radical? So that would be radical 5 times 10, which would be radical 50. Multiply the radicands, boom. Step 3, if possible, simplify the product. So radical 50, can we simplify that? Oh yes, a perfect square that goes into 50 is 25, so we can simplify it to radical 25, radical 2, and radical 25 is 5, so that would be 5 radical 2. Let's look at the next one. Step 1, let's simplify any radicals possible. So radical 2, can't simplify that anymore, but radical 192, what's the highest perfect square that goes into 192? 64, so that would be 3 radical 64. Then 192 divided by 64 is 3, so that would be 3 radical 64, radical 3. Times 5 radical 2. Let's keep on simplifying. That would be 3 times 8 radical 3 times 5 radical 2, which would be 24 radical 3 times 5 radical 2. We simplify the radicals as much as possible. Now let's multiply the coefficients. 24 times 5, we're multiplying our coefficients. So 24 times 5 would be 120. And now multiply the radicands. 3 times 2 would be radical 6. Now we're on step 3. Continue to simplify if possible. We can't simplify radical 6 at all, so this is our answer. And let's look at the third one. Whenever it says it's being squared, I want you guys to write it out as every factor. This lets you not make any mistakes. So I'm going to write this out as 1 over 5, radical 5, times 1 over 5 radical 5. Please do this. Everyone can multiply these once you get the hang of it. But once you get the hang of it, and if you don't do this, so many people make mistakes. I see it from September to June every single year. So make sure you write it out like this. Write out the two factors so you don't make that mistake when it counts. And now do the multiplying. So simplify the radicals. Can't do anything there. Now let's simplify and multiply the coefficients and radicands. So multiply 1 over 5 times 1 over 5. That's 1 over 25 times 5 times 5 would be radical 25. So we did all the multiplication. Now we simplify further. So that would be 1 over 25. And radical 25 is 5, or we can write as 5 over 1 if that's easier to do the math. That equals 5 over 25. Continue to simplify one more step. That would be 1 over 5. All that work just to get 1 over 5. Let's do the next two. The fourth one on the bottom left, I want to show you guys why it's, to me, very important to simplify the radicals first before you go multiplying, which you could. You could go multiplying first. I'm going to do that for this one. So if I were to multiply the coefficients first, that would be negative 4 times 3, which would be negative 12. And then we have to multiply the radicands. So 98 times 54 would be radical 5,292. And then a to the 7th times a to the 8th, that's not too bad. A to the 15th. But I'm finding the highest perfect square that goes into 5,292 is a lot more difficult than if we were just to simplify the radical first. So let's simplify the radicals first. So we have negative 4. The highest perfect square that goes into 98 is 49, because 49 times 2 is 98. So we would have negative 4 times radical 49 times radical 2. Then a to the 7th would be, we can also simplify the a to the 6th, radical a to the 6th times radical a. And then the highest perfect square that goes into 54 would be 9. So this would be 3 radical 9 radical 6. A to the 8th is a perfect square. Let's keep simplifying from there. That would be negative 4 times 7 radical 2 a to the 3rd radical a times 3 radical 6 a to the 4th. So we're just simplifying each part of the radical. Let's write it so every number outside of the square root is in the front. And then everything inside of the square root, we just write it under one square root. So this would be negative 28. Negative 28. A to the 3rd radical 2a times 9a to the 4th radical 6. So now we don't have to try and find the highest perfect square that goes into a very large number. We now just have the radical simplified, so we can multiply the coefficients and multiply the radicands. So when I multiply the coefficients, 28 times 9 is 252. Well, it's negative 28, so it'll be negative 252. A to the 3rd times a to the 4th, you add the exponents, a to the 7th, and now we multiply the radicands, that'd be 12. 6 times 2 is 12. Can I simplify what's inside the radical anymore? Sometimes you'll be able to, this time you can't. So that would be our answer. And the last one, we have a binomial times a binomial. We want to double distribute, so we have to multiply everything on the left by everything on the right. So I'm first going to do the 2 times 7. And now we have to do the 2 times radical 10. Well, I guess I should have checked if the radicals are simplified. They are, so now let's do our multiplication. So now that would be plus 2 times radical 10, which is 2 radical 10. So we did the 2 on the left by everything on the right. Now we have to do the negative radical 10 by 7, so that would be minus radical 10 times 7. And the last part is negative radical 10 times positive radical 10, so minus radical 10 times radical 10. Simplify what we have. 7 times 2 is 14. 2 radical 10 stays 2 radical 10 minus 7 radical 10. And then negative radical 10 times radical 10 minus 10. Or radical 100, which would be 10. Combine like terms. You should get 4 minus 5 radical 10. And that's our answer. So that is multiplying radicals. Now let's go on to dividing radicals on the next page. When we are dividing radicals, the rule for dividing radicals is we can never have an irrational denominator. We have to always have a rational denominator, never an irrational one. So when you look at radical 15 over radical 3, we have an irrational denominator here. So how are we going to make this a rational denominator while keeping an equivalent expression? The way we're going to do that is we're going to multiply the numerator and the denominator by radical 3. So we're going to multiply the top and the bottom by radical 3. And I want to explain why we're doing that, how it works, before we go about doing that. So if you think about when we were adding fractions, like let's do 1 over 2 plus 1 over 3. We couldn't add this right away because we don't have a common denominator. And in order to do that, we would change 1 over 2 and 1 over 3 so they would have a common denominator. So we'd multiply the top of 1 over 3, the numerator and denominator, by 2 over 2. And we'd also multiply 1 over 2 by 3 over 3. This would give us equivalent fractions, 3 over 6 plus 2 over 6. And we rewrite them so we have a common denominator. That's essentially what we're doing here. And why were we able to multiply by 2 over 2 and still keep an equivalent fraction? Well, if we multiply by 2 over 2, 2 over 2 is really just 1. So we're really multiplying by 1, which keeps the same number. So that's what we're doing up here. We're multiplying by radical 3 over radical 3. But radical 3 divided by radical 3 is really just 1. So we're actually not changing the number at all. We're just rewriting it so we have a rational denominator. So when we multiply by radical 3 over radical 3, we get radical 15 times 3 is in the numerator over radical 3 times 3. Continue to simplify that. That would be radical 45 over radical 9. And now, if you notice, we have a rational denominator. It's radical 9 is equal to 3. So I'm going to continue to simplify the top. That would be radical 9 times radical 5 over 3, which then simplifies radical 9 as 3 times radical 5 over 3. And the 3's cancel out to 1 and 1. So our final answer is just radical 5. So the biggest step is that multiplication of the radical part of the denominator in both the numerator and the denominator. Why do we do that? Because we want the denominator to be rational, not irrational. And why are we able to do that? Well, radical 3 divided by radical 3 is really just 1. Anything divided by itself, so we could do radical 10 divided by radical 10. That is really 1. So when you're multiplying a number by radical 10 over radical 10, or any radical number divided by any radical number, you're just really multiplying by 1, so it's staying the same. Let's look at number 2. 3 radical 6 divided by radical 6x divided by radical 5x. So we want to multiply the numerator and the denominator by what the radical is in the denominator. That's going to help us rationalize the denominator. So here I'm going to multiply by radical 5x over radical 5x. So we're going to multiply that in the numerator and the denominator. We're going to get in the numerator 3. Then you multiply what's inside the radicals, 30x squared, all over 25x squared. And now we continue to simplify the numerator and continue to simplify the denominator. So 30, any perfect square that goes into 30, it looks like it does, but it actually doesn't. But the x squared, radical x squared, is just x. So the numerator would be 3. 3, and then the x comes out from radical x squared, radical 30, over 5, because it's radical 25. Radical x squared is x. Can I simplify anything here? Actually, the x's cancel out. So we cross out the x. That becomes 1. Cross out this x. It becomes 1. So we have 3 times 1 times radical 30 on the top, which is just 3 radical 30. And on the bottom, 5 times 1, which is 5. And that is our final answer. Looking at the last one of the top 3. So I erased a little bit so we have more space here. So radical 45 divided by radical 2 radical 20. We could multiply the top and bottom by radical 20 here, so we get the irrational part out of the denominator. I'm not going to want you guys to do that, though, because it's going to be a little bit more difficult. What do you think we should do here to make it a little bit more easy on us? It's similar to what we did for other simplification of radicals. We want to simplify the radicals if we can, so we are working with smaller numbers. So I'm going to first look at the numerator. We have radical 45 here. So I'm going to simplify radical 45 into radical 9 radical 5, which is 3 radical 5. So that's what I'm going to write in my numerator now. It's going to be 3 radical 5 over 2. And I'm going to simplify the 2 radical 20, or just, I guess we really just need to do the radical 20 here. So radical 20 would be radical 4 radical 5, which is 2 radical 5. So that's what I'm going to plug in now instead of radical 20. Continue to simplify that denominator a little bit. So the numerator doesn't change. It's 3 radical 5 over 2 times 2, 4 radical 5. So you could multiply the top and bottom by radical 5 here and go about that way. I think the easier way is, look at that, radical 5 divided by radical 5. Those are the same factors, so we can cancel out and write 1 and 1. So it's 4 times 1 and 3 times 1, 3 times 1 in the numerator. So that just cancels out to 3 over 4. And you could multiply the numerator and denominator by radical 5. It's just going to be a little bit more work for the same answer. Looking at the next expression, 5 radical 3 divided by 6 plus radical 7. First off, I want to know, how is this expression a little bit different than the other 3 we've done? How's it a little bit different? Well, look at the denominator. We have 6 plus radical 7 instead of just a radical like in the first 2. Or in that third one, a number times a radical. We have a number plus a radical. So that's going to change a little bit what we have to do. And one other thing, how do I know I have to change how this expression looks? Why can't I have it written like this? Well, the denominator is an irrational number. We cannot have an irrational denominator. We have to rationalize the denominator and make it rational. So I want you guys to take a couple minutes. I want you to pause the video. I want us to try to make this denominator to be rational. So what would you multiply on the top and the bottom to make that denominator rational and keep the same number? Most students do this. They say, oh, we can multiply the numerator and the denominator by the irrational part of the denominator, which is radical 7. Watch what happens then. In the numerator, we get 5, then 3 times 7 be radical 21, all over 6 times radical 7 is 6 radical 7. Then radical 7 times radical 7 would be just 7. Why do I still have to change what we just wrote? Well, we still have the denominator is still an irrational number, so we haven't rationalized the denominator yet. We have done nothing wrong mathematically. It's just not helping us get to where we need to be. So we don't want to multiply by radical 7 in the numerator and the denominator. What we're going to want to do is we're going to want to multiply by the conjugate. The conjugate, if you check out the box there, of the denominator. And you'll see why in a second. So the conjugate of a binomial, 2 terms, is made by changing the operation from adding to subtracting or subtracting to adding. So if you look at our denominator here, we have 6 plus radical 7. So our conjugate is going to be 6 minus radical 7. And you need to multiply that not only in the denominator, but also the numerator. So we maintain an equivalent number. And notice 6 minus radical 7 divided by 6 minus radical 7 is still 1. So we're multiplying by 1 and not changing the value of the number at all. When you do this, make sure you distribute correctly. 5 radical 3 times 6 would be 30 radical 3. Then also 5 radical 3 times negative radical 7 would be minus 5 radical 21. All over, and do the same thing in the denominator. So make sure you double distribute. 6 times 6 is 36. 6 times negative radical 7 is minus 6 radical 7. Plus 6 radical 7 for radical 7 times 6. And the last one, positive radical 7 times negative radical 7 would be minus radical 49. So here is why we have to multiply by the conjugate of the denominator in both the numerator and the denominator. Because when we simplify this, well, the top stays the same. There's no like terms there. Minus 5 radical 21. And now this becomes 36 minus 6 radical 7 plus 6 radical 7. And then radical 49 minus radical 49 would be minus 7. When we go to add like terms in the denominator, look what happens to the radicals. Those are the irrational parts of the denominator, but what's negative 6 radical 7 plus 6 radical 7? Well, they cancel each other out. You get 0. So when you simplify this further, you would get 36 minus 7 in the denominator, which is 29. And the numerator doesn't change. Can't do anything with the numerator, so it'll be 30 radical 3 minus 5 radical 21. And that is fully simplified. We can't factor anything else out. And that is a fully simplified answer for 5 radical 3 divided by 6 plus radical 7. Looking at that last one, 4 minus 3 radical 8 divided by radical 5 minus 9. I want you guys to take 3 to 5 minutes, try and simplify this as much as possible. Pause the video and play it when you're done. So I know I need to change how this is written because I have an irrational denominator. But before I do anything, to make it easier on myself, I'm going to simplify all of the radicals first. So looking at that numerator, I can simplify that a little bit. So 4 minus 4 minus 3 radical 8 becomes 4 minus 3 radical 4 radical 2, which then becomes 4 minus 3 times 2 radical 2, which is 4 minus 6 radical 2. So that's going to make it a lot easier for me. Instead of dealing with 8, I'm dealing with 2 inside the radical. That's going to be a little bit easier. So I'm going to rewrite my fraction as 4 minus 6 radical 2 all over radical 5 minus 9. Now that denominator, it's irrational. It's also a binomial because it has 2 terms. So I'm going to want to now multiply that numerator and the denominator by the conjugate of the denominator. So that would be radical 5 plus 9 is getting multiplied to the numerator and the denominator. So let's multiply. Make sure you put the numerator and the denominator in parentheses too. So remember to double distribute everything. So in the numerator, I got 4 times radical 5, which is 4, just 4 times radical 5. Can't do anything there. 4 times 9 plus 36 minus 6 radical 2 times, or negative 6 radical 2 times radical 5 would be minus 6 radical 10. And finally, negative 6 radical 2 times 9 would be minus 54 radical 2. All over. Whew! Radical 5 times radical 5 would be radical 25, or 5. Radical 5 times 9 plus 9 rad 5. Negative 9 times radical 5 minus 9 rad 5. And negative 9 times positive 9 minus 81. Simplify that numerator. Nothing going on there. We can't, there's no like terms to add there, unfortunately. But the denominator, we see that the 9 radical 5 and minus 9 radical 5 cancels out. So we have 5 minus 81, which is negative 76 in the denominator. And our numerator, staying the same. 4 radical 5 plus 36 minus 6 rad 10 minus 54 rad 2. So we have a common factor in every term in the numerator and the denominator right now. So we can cancel out you can factor out a 2 from everything. So take out a 2 from 76, or divide 76 by 2 and you get negative 38. Take out a 2 of 4, you get 2. 36 divided by 2 would be 18. 6 divided by 2, we're up to 3, and 54 divided by 2 is 27. So I'm going to rewrite that. We'll have 2 rad 5 plus 18 minus 3 rad 10 minus 27 rad 2 all over negative 38. And just one more step, like rules in English, like you need a period, a question mark, or an exclamation point at the end of a sentence. You need to, capitalize names. This is kind of a rule like that. We never want to have the denominator be negative. So we're going to bring that negative up to the top and just change each sign in that numerator. So we're going to have this be equal negative 2 rad 5 minus 18 plus 3 rad 10 plus 27 rad 2 all over 38. And that is our final answer. Completely simplified. So I just want you guys to do the success criteria, make sure you're all good. The classwork is after, and also the homework.